Hey everyone, today we're going to talk about P4 in your pre-calc book. This is going to be about lines, so graphing and equations of lines. And our objective here is students will be able to write equations for lines in point slope form. That is my favorite form of a line. I'm sure you all have a favorite form of a line too. And if you don't, I hope that you will join me in enjoying point slope form. So let's take a look. So our vocabulary here, just line in general. Delta, which is a big triangle, it's the capital Greek letter, which means change. Slope we'll obviously talk about, and then the intercept, and we'll talk about point slope form. Alright, so let's start with some bell work, the inequalities, which we did in the last section, and then also see what you remember about lines. So give A, B, and C a try, and then we'll come back in a second. Alright, hopefully you had a chance to give these a shot. Let's try the inequality first. There are a few ways to do this problem, and I'm going to kind of do it the way that I think is the most straightforward. So I'm going to start by multiplying everything by -5. Now because that number is negative, what do we have to do? Remember, we have to flip those signs around. So I'm going to have -20 less than or equal to -3x minus 4 less than or equal to positive 30. That makes sense to me because -20 is less than 30. If you left it the other way around, it wouldn't make any sense. Now I'm going to add 4 to everybody, so I'm going to come over here. -20 plus 4 is -16. That's less than or equal to -3x, which is less than or equal to, we add 4 here, 34. So now we're going to divide by -3. And when I do that, remember those signs are going to flip again. So I have 16 thirds greater than or equal to x, greater than or equal to -34 thirds. So interval notation, bracket, -34 thirds, always left to right, so bottom to top, comma, 16 thirds, close bracket. Cool. All right, next up, we've got this line. So hopefully you recognize that this is in slope-intercept form. This line has a slope of -1/2, and it has a y-intercept of 8. If we were to graph it, 8 is like, let's say right here, slope of -1/2, excuse me. And that's more or less all we can say about the line for now. It goes downwards. Every time that you drop 1 unit, you have to go 2 units to the right. So rise over run, remember, with the slope. We'll talk about that on the next slide. Next up, any equation we want to line through this point with this slope. We have a point and a slope, so hopefully you remember what point slope form of a line is. In this case, it's going to be y plus 4 is equal to the slope 2/3 times x minus 3. Kind of looks like the equation for a circle because it's like you have that HK thing going on. X minus the x coordinate, y minus the y coordinate, and the slope in front. If you went a little further and put this into slope-intercept form, let's see what we would have. If you distribute there, we have y plus 4 equals 2/3 x minus 2, and then subtract 4, y equals 2/3 x, then it would be minus 6. Okay, so if you went a little further, that's just fine. But I prefer point-slope form just because it's so much easier with a point and slope. All right, so speaking of slope, let's talk a little bit about it. So the slope of a line has to do with what's called the rate of change. That's a fancy word for slope. We talk about that a lot in calculus. So the rate of change of a function is how much the function changes for every unit that x moves. So if you draw a graph of a line, let's say something like this, the first way you ever learn slope is rise over run, right? I think that's the first way that everybody always learns slope, is how much do you rise and how much do you run, right? So in this case, it looks like if we rise 1 unit, maybe we run 3, I don't know, something like that. And it doesn't matter, the ratio will never change, right? If you rise 2 units, how far out are we going to have to go? Hopefully you know that it's 6, right? That's that linear relationship. It never changes. So the slope, which we always use m for, I believe that's a French word. It's something having to do with change. I'm no French scholar, so maybe some of our French students in the class or those that run French immersion will be able to tell us about it. But the rise over run never changes. So whether it's rise 1, run 3, or it's rise 2, run 6, it's always going to reduce down to the same fraction. You can go backwards too. You can go down 1 and back 3. So -1 and -3. Doesn't matter how you look at rise over run. It's always going to be the change in y over the change in x. Like we said, that triangle is the capital delta. So this is the change in function, or the y value, and this is the length of the interval. So length of the x interval. So how far do you go and how much do you rise or drop? A negative slope, of course, would be something that goes downwards. Same deal, right? Rise over run, rise over run, rise over run. It never changes. That's the whole idea of slope. So the equation for slope, you need 2 points, right? You have your first point and your second point. This is x1, y1. And this guy right here, let's say, is x2, y2. Well, if you're going to find rise over run, the rise is the change in y, right? So that's going to be y2 minus y1. And then the change in x is going to be x2 minus x1. Now, notice it doesn't really matter which order you do it, right? We said you could do the negative over the negative or the positive over the positive. It doesn't make any difference. You could also do this if you multiply the top and bottom both by -1 and distribute it. You end up with y1 minus y2 over x1 minus x2. So as long as you go in the same direction for both of them, like for this one, you wouldn't want to do like -1 divided by a +3. You have to go in the same direction for both of them. So this is kind of our slope equation that we're going to be dealing with today. All right, so let's get into the point slope equation for a line. So do you remember our equation for a circle where we said basically we're looking for some formula that only works for all of the xy points on the circle, right? This is xy, xy, right, all the way around. We're looking for a formula that works for only those points. Like this point would not work, this point would not work, this point would not work. Only those exactly on the circle work. That's why there are x's and y's in that equation. We want the same thing for a line. So this is actually, I think, one of the simplest derivations of a formula. Let's say this point right here is x1, y1. So that's a point that we know. Maybe that point is like 5, 4 or something. I don't know, okay? But that's a point that we know for sure. Think about what every single one of these points has in common. It's nothing to do with distance, right? On the circle, we use the distance formula. Every single one of these points is not the same distance away from our x1, y1. Let's change the color of that maybe so we can see it better. Okay. So that x1, y1, that is like our point where everything is starting from. But what each of these points do have, think about this, right? We just talked about it. Do you agree that the slope to every one of these single points is the same? Some of them go backwards, but they also go down, so the negatives would cancel. Some of them go forwards and up, but the slope of every single one of those is the same. So let's think about each of these as being an xy. So I want some kind of formula where I use that xy and this x1, y1 that will always give me a constant value. That constant value is the slope. And so then we have, let's use like this point right here. So y minus y1 over x minus x1, right? This is just our slope formula. And you could do that for any single point on the line because the slope will be the same for everyone you use. Now, watch this. Most beautiful formula ever. Let's just multiply by the denominator. X minus x1, x minus x1. Now these will cancel. I'll just rewrite it a little bit. We have y minus y1 equals m times x minus x1. This is point slope equation for a line. That's it. It's just the slope formula multiplied by the denominator. There's nothing more to it. So this is what we call point slope formula or equation for a line. And it goes through the point x1 comma y1 and has a slope m. Super easy. Oh, jumped ahead a little bit. Okay, so if you know the slope, you know the point, you can automatically get an equation for a line. Let's give it a shot. So, because you guys have seen this before, why don't you give these a shot? So go ahead and pause the video for a second, try this. All right, let's see how you did. So the first one, we have the point, we have the slope. So we're just going to put it into our formula. Y minus y1 equals m times x minus x1. Remember, there's going to be an x and a y in our final equation because we need to have it generic for any point. So here we have y, looks like plus 4, is equal to our slope 2 times x plus 3. That's it. That's all there is to it. So what do you need to make a line? You need a point and a slope. And that makes sense to me because, and this is, I talk about this in calculus all the time. It's going to be on the whiteboard all year because we talk about point and a slope all year long. But it makes sense to me because if you just have a slope, think about it this way. If you just have a slope, it could be any one of these lines, right? Any parallel line, because they all have the same slope. If you just have a point, then it could be any one of these lines, right? It could be any line that goes through that point. But if you have a slope and you know it goes through this point, then this is the only line that works. It's like it fixes it in place. There's nothing else that can be used. All right, let's give this one a shot. This time we have 2 points. Well, if we need a point and a slope, that doesn't sound very good. But wait, we can get the slope, right? Let's do change in y over change in x. Let's have this as our second point and this is our first point. So we're going to do change in y, -2 minus 2, over, now because I went that way, I have to go that way with the x is 2. So 4 minus a -1. This is our slope. So that's going to be, let's see, -4 over 5. So we have our slope. Okay. Notice if you went the other way, you would have had 2 minus -2 divided by -1 minus 4. That would have given us a +4 on the top, and on the bottom a -5. Remember the first day of class we talked about this. Doesn't matter where the negative is, same number. Okay, so we have our slope. Now do you think we can use either point? Absolutely. That's like having this point and this point. Doesn't matter which one you use, it will give you the same line. Let's use point 2. So we have y plus 2 equals -4/5 times x minus 4. And if you use the other point, y minus 2 equals -4/5 times x plus 1. If you want to try as an exercise, we're going to focus on this in the next video, but if you want to try distributing this out and seeing if these two lines give you the same formula in slope-intercept form, you can give that a shot. Alright, so the next video is going to focus on slope-intercept form as well as perpendicular and parallel lines. So I will see you for that for P4 Part 2. Thanks for watching, guys. Love ya.